Hello to everybody who signed on a little bit early. We'll begin in just a few minutes, so please hang tight until then, but we will start at 2 p.m. sharp. Good day, everyone. Welcome to today's presentation, Labor Savings and Engineering Benefits for Underground Construction, sponsored by Champion Fiberglass. My name is Colleen Beatty, and I'm the senior editor here at Electrical Contractor Magazine. On behalf of the magazine, I want to thank everyone for attending today's presentation. So before we get started, I just want to go quickly over some housekeeping items. First, please note that today's presentation is being recorded, and we'll be providing you with a link to the recording after the webinar is over. So if you miss anything or if you have to leave early, that's all right. You can come back anytime and watch the recording when it works for you. The audio for today's presentation should be coming through your computer speakers or headphones, but if you have any technical difficulties, audio or otherwise, just reach out through the Q&A window on the left-hand side of your screen. And of course, we encourage your participation in today's webinar, so please send us your questions. You can submit them at any time during the presentation using the Q&A module, again on the left of your screen, and we'll have time at the end of the webinar to answer them. There's also a quick survey that should pop up on your screen at the end of the webinar, and we hope you'll fill that out. Or if you'd like to fill it out sooner, just click the icon with the clipboard at the bottom of your screen to open it up. So with all that out of the way, I'd like to give a warm welcome to today's speaker, Matt Fredericks, who is Director of North American Business Development for Champion Fiberglass. Welcome, Matt.
Hey, thanks, Colleen, and thanks for Electrical Contractor Magazine for having me here today. Super excited to talk about a couple tips, tricks, and nuances to underground construction. So really what we're going to be talking about today is essentially why underground construction will help labor savings in the long run. So there's certainly things that you can do ahead of time to prepare for proper underground construction, proper cable installation and conduit installation. But what I wanted to touch on first is why underground construction is a good thing. So as far as labor savings goes, underground power infrastructure as well as underground communications infrastructure will actually lengthen the lifespan for the cable and the conduit. That's because the cable and the conduit isn't exposed to any natural disasters or hazards above grade. It's been shown to lengthen the actual infrastructure of the power and communications cable exponentially, really. Additionally, things that can also help with underground construction are things like prefabrication. If you prepare ahead of time, this will actually reduce the time in the field and the overall cost of the installation. Certainly, talking about trench safety quite a bit recently, this increases the contractor's safety by keeping folks out of the trench as long as humanly possible. As well, it mitigates extreme weather challenges. Certainly doing construction all over the states, things like hurricanes, tornadoes, rain, snow, what have you. If you can create your system as much as possible inside beforehand, this will help mitigate the problems in the long run. Next, we'll talk about the 𝐼𝐴 labor rates, which is among the many tools that you can use to properly estimate how long construction will actually take. So these rates that you're seeing are from the actual 𝐼𝐴 Manual of Labor Units, National Electrical Contractors Association. This chart is a chart that Champion Fiberglass created. It's the data that comes from the 𝐼𝐴 Manual of Labor Units, all aggregate together. So if you're looking at this chart right now, this is a great way to actually estimate how long it's going to install conduit 100 feet, and this is derivative of man hours. What is important to note is the man hours that are indicated on this chart are actually all to install at chest height. It isn't for underground. What we find is that installing underground, the labor rates are actually much lower than this. Elbows follow the same suit, and it's important to note that if you look on this chart here, there are certain conduit types, as well as sizes that indicate savings for underground elbow construction as well as conduit construction. For longer radius sweeps, with the exception of fiberglass, you actually add 20% to the labor for those. Fiberglass being lighter will actually save you time in the long run for installation. So a couple tips about engineering for underground construction. First of all, if you are choosing to go underground instead of above grade, again, the benefits are going to be in the long-term cost savings. Underground construction is going to help you save money long-term. There's no risk for cars hitting telephone poles or power poles, hurricanes, natural disasters, what have you, and that cable is protected either in a direct burial application or in conduit. That infrastructure longevity will actually yield you savings, whether it's on a commercial industrial project or on a utility project. Some things that I would recommend as far as best practices for underground construction is utilizing a lot of the available technology that's out there now. One of which is BIM Revit modeling, which can be especially helpful if you're doing any type of commercial industrial application, trying to plan for underground construction there, because this actually incorporates a lot of different other utilities and or cabling, conduit, or what have you into the modeling. Certainly manufacturers like us, as well as many other manufacturers, have available BIM Revit modeling that's accessible for anybody to use and download. Additionally, prefabrication, like we said prior, is a super important thing to include. There's numerous contractors that we work with on a daily basis that have absolutely amazing prefabrication shops where they're pre-assembling duct banks, putting them on flatbed trucks, hauling them to the site, and simply dumping them into the trench. It's an amazing feat to see and a huge cost in labor savings. Additionally, considerations for what type of conduit and cable you need are going to, essentially come down to what environmental factors you have and what type of infrastructure you're putting in. If you're going to put in something like fiber optic cable and you have the ability to blow it through HDPE, directionally drill in that conduit, that might be the easiest thing for you to do. If you have heavy soil compaction, maybe it's something like using a heavier PVC or a heavier wall fiberglass or perhaps steel. It's always important to essentially pick the right hammer when installing underground, because if you don't, serious consequences can arise. So a couple other softwares that I would recommend besides that BIM modeling would be something like a pulling tension software. Certainly American Polywater and Southwire have had pulling tension softwares out there for a long time. We'll be releasing our own pulling software too. All three of the programs have different features and benefits to them, so pick the one that best suits your needs. Project databases are really helpful too if you're a contractor that's interested in getting into more underground construction projects. Things like Construct Connect or Trimble, where they're showing a lot of these projects that are out for bid, can be incredibly helpful to see A, what type of projects are out there, and B, what type of conduit and really any other types of materials that other contractors or engineers might be specifying or using. Estimating software seems to be extremely helpful for a lot of the contractors that we're working with right now. There's an absolute plethora of estimating software that one can use. Certainly, there's different labor rates that have been populated in there, certain price points. But from what I hear from the contractors that we talk to, these types of softwares can be critical in appropriately estimating cost and budgeting for different projects. And finally, Trimble. We here at Champion are fans of Trimble Tracer. We actually supply them with information for our costs for their estimating software. But there's a number of uses for Trimble, including job site mapping and other things that our contractors are using as well. So types of cabling for underground construction. I'm not going to belabor this point, but of course, most of you know that there's really three different types of cabling that are going to be used. Low voltage is going to be for your residential and communications. I would lump fiber optic cable under that, limited power. So that's going to sort of fit into what type of underground construction you're doing, what type of conduit you're using, how you're going to plan. And then medium and high voltage follow similar trends. Medium voltage is going to be for your standard power distribution or larger power needs. And then, of course, high voltage is for transmission and power distribution. Interestingly enough, high voltage is an area that we've seen a lot of overhead construction for many years, but we're starting to see a lot more high voltage transmission lines go underground so they can save time, money, and labor over time due to the fact that it won't be exposed to the elements or weather events. So what types of conduit are used for underground construction? So specifically on the electrical side of life, we're really looking at PVC coated rigid, galvanized rigid, Schedule 40 and Schedule 80 PVC, as well as fiberglass conduit. I will mention too that HDPE is being used in stick or in roll pipe format, but for the purposes of this presentation, we're really going to focus on that stick pipe style of conduit. So why is GRC used? Well, really it's used in a lot of areas of heavy soil compaction, areas that need mechanical protection. But it is very heavy, so that can be cumbersome in a trench. That's why oftentimes things like Schedule 40 and Schedule 80 PVC are used for everyday use, either for short runs or underground distribution. Additionally, if you were in an area that really had quite caustic soil, but also had heavy soil compaction, rather than taping a whole piece of galvanized rigid conduit with anti-corrosive tape, you could use something like PVC-coated rigid steel conduit. Now, fiberglass conduit in general is really good for a number of different types of soil, whether it be heavy soil compaction, corrosive soil, everyday use for longer runs, as well as for underground power and distribution, as well as transmission. So what can you do to prepare for underground installation as far as the site is concerned? Well, really, you need to look at what's happening on the site. What's the existing infrastructure in the ground? There are many, many associations that are making huge efforts to get underground utilities fully mapped. It's happening with organizations like PDI Squared, Common Ground Alliance, PCCA. This is a huge effort to make sure that utilities, when they're being put in, whether power, communications, gas, water, are not running into each other. So great idea to really get an idea of what existing infrastructures are existing there. You also want to pay attention to, of course, what are the soil conditions, caustic or corrosive or not? Is the water table high? Does it go under a roadway or a driveway or a parking lot? Those are all things that one needs to consider when thinking about what type of conduit you need, what type of cable you need, really how you're going to construct your underground install. So there's certainly underground installation pitfalls that happen. One of which is going to be having insufficient machinery on hand for pulls. I've been on a number of pulls now, coming from the manufacturer's rep side, where I represented a company that manufactured pullers. And what we often see is either there's an underpowered puller, there's no puller, perhaps a contractor utility may be pulling with something like a vehicle. It's really best to have a great puller that's got a running line tensiometer on it. It's going to actually measure the tension of the pull from start to finish and have enough power to make the pull happen. Additionally, things like pulling shivs, quad blocks, many different items can make a pull much easier. Swivels, grips, have everything on hand. Make sure that you've got those from the start, because it can be a real pain having to run back and forth to a shop or having to rush the materials if you haven't purchased them already. Like I said before, really the lack of pull tension monitoring and data, from the pulling process can be a real liability now. There's a lot of cable manufacturers that are requiring pull data for their warranties. Cable manufacturers put in a lot of time and effort into engineering their cable, making them as robust as possible. But there's certain limits that are on the cable for pulling sidewall pressure. So using, one of the softwares that I mentioned early on for pulling it is very helpful, of course. And then having that real-time pulling tension monitoring is very important as well. So best practices for underground pulling. I would say honestly, selecting the conduit type and cable to use is probably one of the most critical things to focus on. Looking at what type of coefficient of friction that cable has with the conduit you're pulling through really can help you meet certain successes as far as keeping pulling tension down and pulling further in that case. What else might you need for success? Get yourself a good pulling rope. There's tons of different pulling ropes out on the market right now. Certainly 𝐼𝐡𝐚𝐭, Conduit, Aaron rope. I'm sure GMP has one. There's tons of different types of pulling rope, but you want a rope that's not going to stretch a ton and create a lot of friction inside of the conduit system. Different types of tools that you need. Swivels are great. That's going to reduce the overall tension of the pull as you're pulling it through sweeps or even straight lengths. Do you want to use a basket style pulling grip? Do you want to use a crimp-on pulling head or perhaps a reusable power pulling eye? There's so many different tools now that you can use to reduce tension on the conductor and pull successfully through an underground cable system, I would say take the time to meet with your local rep from any type of pulling equipment manufacturer, or really any company that helps you with pulling success. And it's amazing the tools that they have now. And then, of course, safety considerations. Certainly pulling underground, being that the conduit is more than likely going to be either buried or in a concrete slurry already, reduces the danger rather than pulling overhead with stringing or something like that, where you have a conductor or rope heavily exposed. But if you're pulling too hard, if you haven't inspected your rope, if the rope breaks, it may have a tendency to pull out of the conduit system, and it could come back, at a 180-degree angle back at you. So always make sure to follow best practices from your pulling equipment manufacturer, and any other safety training that you've done. And certainly make sure that your time in the trench is limited as well. So challenges for underground construction. Many things to keep in mind. One that I would say is a common issue that folks have come into for many years now is dealing with burn through. And what burn through is it's actually illustrated in the picture on your screen right now. It's when a pull rope or a wire braided rope essentially gets too hot on the inside edge of a PVC elbow, and it can actually slice right through the inside edge of that elbow. So for many years, engineers have been specifying galvanized rigid or PVC coated sweeps. You can actually use a fiberglass sweep as well. Those don't burn through. So that would be something to consider. If you're using a GRC sweep, or especially a fiberglass sweep, that's going to reduce the overall tension and sidewall pressure when you're pulling through a sweep. But if you've ever burned through a sweep, it's a real bummer. So make every effort to make sure that you're not going to burn through one of those sweeps. Field handling with heavy conduit. Man, that can be, again, a serious difficulty. Make sure you're using a lightweight conduit that's going to meet the needs of the installation, but again, being as light as possible. Cuts and abrasions and back injuries really, I believe, are two of the worst things that can happen on an electrical install job site right now, let alone, of course, arc flashes. But certainly be mindful of keeping weight off of the workers when they're installing conduit. Trench safety, the faster you can be out of the trench, the better. Companies have made huge strides and are obviously very mindful of using shoring, making sure that there's tons of safety associated with the trench. But we know certainly being above grade and not in a trench is a safer place than being in the trench. Fault concerns are another thing to consider. If you have a cable fault on the inside of metallic conduit after the install goes, this would be for really the maintenance and operational part of underground construction. That cable will actually weld to the inside of metallic conduit. And if a fault occurs in PVC conduit, it will actually melt to the inside. I will mention that fiberglass conduit is not affected by cable faults. So that is a consideration when you're installing underground cable, is if it is conduit. In conduit, you want to make sure that it's in a fault-resistant conduit. Materials cost, I'd go back to the estimating software and combine it with labor rates. Make sure that you're taking a holistic view of what material costs are. Sometimes materials might be slightly more, slightly less, but that labor rate really is not going to change based on what the material is. The cost might go up and down. The labor rate is not going to. So couple those two items together, and that may be helpful for you to determine what type of conduit you want to use in underground construction. Now, another thing I will mention is say you need things like custom offsets, large bends, you're going around a water tower, an existing building, what have you. make sure the conduit type that you're using, really anything that you're going to be using, is going to meet the needs of those complex installations. There's so many custom solutions now that companies can make. Partner yourself with companies that will meet those needs for custom solutions. A couple other things that I will mention too. I would say that when you're doing underground construction, it's certainly important to read those UL listings and the NEC code. Also, if you're a utility, pay attention to the NESC code. Those three things will really guide you on what's able to be used and what's not able to be used in many different situations for underground construction. Additionally, local utility codes, as well as building standards, will guide you as well. There might be specific conditions in the area that you're doing construction in where specific soil types are present. So a utility or the building codes may require that metallic sweeps be wrapped in non-corrosive tape. Just the nuances of doing construction everywhere. So it's important to pay attention to those, make sure that you're in compliance. One other thing that I'll mention too, really on the manufacturing side, is pay attention to quality standards too. Saying that you have high quality is certainly one thing, but see if they have quality compliance documentation or processes that they might offer to you. Another, more obvious one that a lot of folks are familiar with would be ISO 9001 ratings, which is a quality management system. Having that is great. It doesn't mean that you don't make quality products if you don't have it. That's just a standard that's available, and certainly manufacturers can apply and maintain that standard as well. I talked about maintaining cable warranties beforehand, but I really can't stress enough how important it is to measure that pulling tension and pull cable in the way that cable manufacturers require you to do so to maintain that warranty. And then, of course, in general, follow manufacturer best practices. There's a reason why they're there. Certainly, there are numerous ways to do things in the field, but generally, if you follow manufacturers' best practices, your installation is going to be far more seamless rather than doing it out of compliance or out of best practices. So just talking about Champion a little bit, I wanted to mention a few things. I'll talk about my first fiberglass elbow experience, just because I think it's important to highlight how versatile fiberglass is and really how it can solve a problem. I was at a local utility down in Iowa, and I was doing a cable demo down there in my previous life. Like I say, was a manufacturer's rep and represented a cable pulling company. So we were pulling cable from a meter socket all the way over to the opposite side of a utility shop underground through a couple different bends. And as we were pulling out of the last 90, the worst thing on the planet happened, which was I burned through the last sweep. And of course, folks were not happy because the elbow and the rope quaked right through the ground. We saw the rope come up through the dirt. Luckily, being that I was a fiberglass conduit rep, I did have an extra elbow in the back of my truck. We installed it right there, and we ended up re-pulling the run, pulling through that last sweep, and nothing happened. So I guess that goes to say that even though the preparation wasn't intentional, I was prepared with the materials on site and certainly used the right hammer for that application. We've also had a couple interesting instances with labor savings for underground construction. There was a data center in Iowa that was able to complete a one-day installation for about 3 miles of conduit. Pretty impressive in a duct bank. They were used to a couple more days than that with a different style of conduit. So again, you look at those labor savings based on size. You math it out based on price, and whatever the math makes sense for you and your company, that's what you should use. And then finally, we also did a coal-fired power plant with a contractor in Edwardsport, Indiana. They were going to use another type of competing conduit. They ended up using fiberglass conduit, and they were able to eliminate numerous faults on the job. And it resulted in seven-figure savings for the job because they were able to pull really 3 times further in our conduit based on what the run had, the way they planned it, versus that competing style of conduit. So I want to say thank you, and then, of course, open it up to questions. Are there any questions on the docket?
Yes, we got several questions in. So first of all, thank you, Matt, for that great presentation. If any of you have any questions, go ahead and put them into the Q&A module on the left of your screen. And if we don't have time today, we can have Matt respond to you after the fact. So first of all, someone asked if you could explain more about the requirements of direct buried quality conduit.
Okay, so DB style conduit comes up all the time. It's going to be essentially a thinner wall PVC style conduit. It's a great option if you're using a concrete encased style of installation. Again, usually used for duct bank applications. But you can use several different types of conduit, including fiberglass, for that type of application as well. So direct burial PVC, there's our standard wall fiberglass, and of course you could direct bury other types of conduit as well.
Okay. Let's see. Can you elaborate on any special buried scenarios that would require a conduit with additional mechanical strength?
Yes, certainly soil compaction is going to be a huge one there. There's a lot of times that folks will come to us and other manufacturers asking about things like railroad crossings or parking lots. We've done natural gas or oil gathering stations. There's, any area with really heavy vehicle traffic is going to be certainly an area where you're going to want to pay attention to that. Same with areas with, ground shifting that's happening as well.
Okay. Well, let's see. Can you give an example where Champion Fiberglass provided a custom solution?
Yeah, several that I can think of. Certainly for underbridge installations, we're constantly creating custom travel expansion joints. We're also doing custom offsets a lot under bridges to go around existing, infrastructure. That goes for underground too, though. There's a lot of times that we're making custom radius elbows, custom offsets, really bends that will allow you to navigate around the existing infrastructure. There's been certain times where we've made very long radius sweeps that will go around things like water towers too, or slight bends that will follow the curvature of a tunnel wall. So yeah, tons of different custom solutions, custom fittings. We're pretty lucky to have quite a large machine shop where we can make a lot of custom molds, which helps with our custom solutions.
Excellent. Let's see. We had some folks asking about safety. So can you talk more about the safety of the different types of conduit and underground construction?
Yeah. In my opinion, you're going to want to use a conduit that's got great mechanical strength, but it's also lightweight. Of course, I'm going to be a fan of fiberglass conduit working for a fiberglass company. Doesn't mean that there aren't other conduit types that meet that. But what I would say is keeping the weight low as possible is going to be important because a lot of this work is performed by tradesmen and women in the trench, and it can be really strenuous work, especially lining up duct banks, things of that nature. So anything that you can do to reduce weight and labor, bending, twisting, really any time in the trench is going to be huge for safety.
Okay. Let's see. So here's another question. Is buried construction on the rise? And like why and what other applications or industries is it on the rise?
Yeah, that's a really good question. It most definitely is. Really buried construction, started out with just putting cable in the ground. A lot of cable was plowed into the ground early on, certainly by a ton of different utilities, electric co-ops, what have you. But it's really been on the rise, I would say, over the past 20 years, again, due to environmental hazards and really just people, wanting to keep the skyline clean or the
Mm,
horizon clean.
mm,
It's a lot nicer not to have to look at a power line or a piece of cable or a conduit. And if you can put it underground, again, the hazards are very minimal because it's being literally protected by conduit and the earth. So we're seeing a lot more underground power and communications infrastructure going in. It certainly didn't touch on it much in this presentation, but talk to any communications contractor in your area, and it's unreal how much fiber they're putting in the ground. They're directionally drilling in HDPE and using a fiber blower or fiber puller to put that fiber optic cable in and give us the high quality, high speed internet that we all love right now. So, yeah, it's AI, data centers, the internet, so many
mm,
things are driving this right now. Super exciting time to be in the industry that we're in.
definitely. I got one more. I think we have time for one more question. We want to be respectful of everyone's time today. Does underground construction help minimize environmental impacts?
Yeah, I mean, here's what I would say. It's interesting. I was just at the IEEE last week. I didn't even know that there was such a thing as an underground substation.
Mm,
Having underground infrastructure, be underground, um, it's really not going to be in the way of any animals or environment. You're not worrying about tree trimming all that much. Certainly with wildfire mitigation,
mm,
there's numerous utilities that have been um, impacted by wildfires where the infrastructure is completely destroyed. And it's a huge deal when those types of disasters come in for the utilities, the customers, the environment, whatnot. Keeping that plant, if you will, underground is hugely impactful for the environment and on a macro level too. If you're having materials that are ending up lasting, quite a bit longer than overhead construction, it's really just less materials that you're having to constantly consume and replace too. So.
mm. And I imagine having all that conduit underground would reduce potential impacts to wildlife, such as bird strikes or possible electrocutions.
Yeah, for sure. Absolutely.
Mm,
Yep. Yep. Yeah, 100%. So yeah, it's very minimal when it's underground, that's for sure.
mm. All right. Well, I think that's all all the time we have for questions today. So if we didn't get to your question today, please don't worry. If you put it in the Q&A, Matt can get to you later today or tomorrow. So on behalf of Electrical Contractor Magazine and Champion Fiberglass, I want to thank everyone here for attending. And a big thank you again to Matt for such a fantastic presentation. So
Thank you.
please don't forget to fill out the survey. It will pop up on your screen when this webinar ends. And if you'd like to be contacted by Champion and we're interested in their solutions, you can answer the question on there about getting contacted in the survey. Also, please be on the lookout out in your email for the recording of this event. It should be coming into your inbox, I think, later today. So I hope everyone has a great rest of your day, and we hope to see you at a future webinar.